Okay, these are the notes for 9.1, circles and parabolas. So we're going to start off with our first example of rewrite the following equation into standard form, then state the center and radius. Now to remember, standard form for a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. So if you remember from Algebra 2, in order to get this into standard form, we need to complete the square. So to complete the square, I'm going to regroup this by putting the x's and the y's together. And I'm just going to rearrange it. And I move that 12, that negative 12 to the other side, because I don't need it. To complete the square, we are going to take our b value, which is our middle term for each of these, and we're going to divide that by 2 and square it and add that to both sides. So for the x, negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Going to do the same now for my y value. I'm going to take that b right there and do the same. I'm going to have y squared plus 4y, divide that by 2. So 4 divided by 2 is 2, squared is 4. And I'm going to add that to that side of the equation. Now the thing to remember is because I've added this 9 and this 4, I have to add them to the other side as well. So I'm going to say plus 9 plus 4. Now we're almost done. So the x squared minus 6x plus 9 becomes x, and it's always going to be a single x because you have no coefficient in front of there. And it's that b divided by 2, so that's that negative 6 divided by 2, so 3. Quantity squared. Plus, now do the same over here. Y, again, take that middle term, divided by 2, and that was here. And then the 12 plus the 9 plus the 4 gives me 25. So we can say that our center is at, hold on, let me get it, 3, and then negative 2, and I don't like that, so I'm going to go back a little bit and make that a little darker so you guys can see it. Is at 3 and then negative 2. And our radius is equal to the square root of this 25. Or just 5. Alright, so that's example 1. Completing a square is going to be an extremely important skill to use in this unit. So if you have difficulties remembering how to do completing a square, make sure you come in and see your pre-calculus teacher right away. It is imperative that you understand how to do completing the square. Alright, on to example 2. Okay, so it's still dealing with a circle. However, for this one, it says find the equation of a circle with a center at negative 3, 5, and its tangent to the y-axis. Well, if you remember what tangent means, with regards to a circle, it means it touches the circle in exactly one spot. So it's going to touch that y-axis at exactly one spot. So I'm going to kind of sketch that a little bit. Alright. I'm going to draw my axes here. And okay. So my center is at negative 3, positive 5. 1, 2, 3, 4, 5. And I don't even need to draw the whole circle. because I know my circle is going to touch that y-axis right in one spot. Now the cool thing is, if you notice, this distance right here, that's going to be your radius. And so our radius is equal to 3. Well, that's enough to write our equation. We know our center already. So x minus h squared plus y minus k squared has to equal r squared. Substitute our values in, and I get x plus 3, quantity squared, plus y minus 5, quantity squared equals, and my radius was 3, so 3 squared is 9. Right? That's that entire problem. Let's move on to number 3. Okay, now we've moved on to parabolas. Now the thing about this is we're going to give you another equation for a parabola. Where before we used to have an a value, we're going to substitute that in for a 4p. And what this 4p allows us to do is get a more accurate picture, because it's given us some more information about our parabola. Now the thing to remember about it is you're going to look at our equation, and if it's an x squared or y squared determines whether it's going to go right or left or up and down. So remember, if it's a y squared, then your parabolas are going to go either open to the right or open to the left. If it's x squared, it's going to either open up or open down. Now to determine whether it opens right or left or up or down, that's where that part of that 4p comes in. If our 4p is negative, it's going to make us have a negative parabola. It's going to have us opening in the opposite direction. So the only way we can tell which way our parabola is opening is by completing a square. Now the equations for a parabola look a little weird. The key thing is we're still going to complete the square, so I'm going to leave my y squared on this side. I'm going to move everything else to the other side. Okay, so I'm going to clean it up a little bit, and I've got a little bit of... So I'm going to put y squared plus 6y equals negative 8x minus 25. So I'm going to get my y squares by itself. Complete the square. Y squared plus 6y plus, remember you're going to divide that by 2 and square it. So 6 divided by 2 is 3. Squared is 9. I'm going to add 9 to both sides. So negative 8x minus 25 plus 9. Okay, clean it up a little bit. So on the left side, I'm going to have y plus 3 quantity squared equals negative 8x minus 16. Now here's where it gets a little different than what you had before, because our two forms of our equations look like this. Y minus k squared equals 4p times x minus h. And the other one would be y minus h squared equals 4p times y minus k. Now whether you have the squared term on the left or on the right side doesn't matter. The key thing is that this squared term, these squared terms, they can only be on one side. You can't have anything else there, so there can't be any 4p's, there can't be anything else on that same side. The 4p's are to be in front of either the x or the y, the one that isn't squared. Okay? So you make sure you get that format right, because you're used to having the a in front of the squared term. There's no more a. It's now something else. It's a 4p. And it's going to be on the opposite side of what you're used to. Okay? So that tells me if you look at our two equations we had here, the non-squared term, in this case it's x, it's got to be a 1x inside the parentheses. So I need to factor out that negative 8. Okay, and once I factor that out, now I have everything I need to be able to graph it. And I also know a lot about my parabola. I know that my y is squared, so my parabola is either going to open to the right or to the left. But also, this is your 4p right here. My 4p is negative. So because my 4p is negative, that means my parabola is going to open up to the left. If it had been positive, it would open to the right. So I know my vertex, and I'm just going to start listing things. My vertex is at -2, -3. My 4p is a distance that we have for everything else. That 4p is going to help me to find where my focus is. It's going to help me find my directrix. It's going to help me find how wide my parabola is. Now the 4p is a distance. So that negative really doesn't do anything. So I can use the absolute value and say I want an absolute value of 8. So 4p is equal to just 8. And my p equals 2. Now you're probably thinking, what does that p help me with? Well, it tells me my focus is 2 away from my vertex, and my line of directrix is 2 away from my vertex. And all three need to be in the same line. I can't say that. That the line of symmetry that goes through the focus and the vertex has to be perpendicular to our directrix. So watch how I graph this. Okay, so I'm going to make xy axis. My vertex is at -2, -3, so let me scroll that up a little bit. -2, and I'm going to actually extend this a little bit more. -2, -3. There's my vertex. Because I know my parabola is opening in this direction. Okay, and I'll erase this later, but it's just kind of a sketch to tell me opening in this direction. My focus is inside that parabola, so it's 2 away from it. So it's got to be right here. So there's my focus. And that's at 1, 2, 3, 4, 1, 2, 3. So my focus is at -4, 3. Your focus and your vertex will always be in either the same horizontal line or the same vertical line, depending upon which way your parabola opens. Now, to find my directrix, I'm going to go 2 in the other direction. Let me find a different color that's going to show up. Let's do a green. Well, 2 away from that is right here. It's right on my y-axis. Okay. And so my directrix is at y equals, not y equals, I'm sorry, x equals 0. Okay. But that doesn't tell me, we still haven't graphed our problem. We're just finding information about it. Now to figure out how wide my parabola is. And that's where my latus rectum comes in. The latus rectum is the distance of how wide a parabola is through the focus. It's connecting 2 endpoints of your parabola, or not two endpoints of a segment from your parabola through your focus. So and it's supposed to be the length of 4p. Well, if 4p is 8, I'm going to go 4 up, 1, 2, 3, 4. So the parabola goes up here. There's the top half. And then I'm going to go 4 on the bottom. 1, 2, 3, 4. So that parabola has a distance of 8 across. So this distance from here to here is 8 units. Okay. Now you're not normally going to write 8 units there. I'm just showing you that this distance across is 8 units. And there's our information. So let's fill in what we don't know. We've already listed the vertex. We need to find the focus. And that was at -4, 3. The directrix is at x equals 0. The line of symmetry is the line that is perpendicular to the directrix. So it's going to be a horizontal line that goes through the focus and the vertex. Well, that would be at right about here. And so that would be y equals -3. All right, and then what's the last thing? The length of our lattice rectum, well, that's just our 4p. And we'll just abbreviate this as LR is equal to 8 units. Okay, that's example 3. Let's go on to example 4. Okay, so this is a little bit different version of the equation, but we're going to still do basically the same thing. We're going to have to rewrite it by completing the square. And the first thing I want to do is I want to kill that fraction. You see that 1/3 in front? I want to multiply both sides by 3. And I'm going to kill that fraction. And that's going to help me out here. Okay. Now the x squared and x are already on the right side, so I'm just going to move that 2. Now remember what I had said before. We just need to keep things separated. That's the important thing. And why did I put an x there? Or y there? I want to put an x. To complete the square, I'm going to take that -4 and I'm going to divide it by 2 and square it, and that's going to give me a +4. So I'm going to add 4 to both sides. Simplify and I get 3y plus 2 equals x squared minus 4x minus 4. Well, that's just going to be x minus 2 squared. Now remember, I need to find my 4p, so I've got to factor out that 3. So I have a coefficient of 1 inside my parentheses, so I'm going to factor out the 3, and I get y plus 2/3 equals x minus 2 squared. All right. So I have an x squared, and I have an x squared, and my 4p is positive. So that tells me my parabola is going to open up. So I'm just kind of sketching it here to remind myself. My vertex is at 2 and -2/3. I'm going to write that up over here. That's the first thing we need to find. Now to get my directrix and everything else, well, let's do the focus first. Since my parabola opens up, that means my directrix and my focus are opposites of each other. I keep talking directrix, and I'm not wanting to talk directrix. Let me draw our axes in, and let's just start sketching it, and that's going to actually help me out a little bit, I think. Okay, so there's my axes. So I'm going to go to 2, -2/3, and I'm going to put a point there. So there's my vertex. My focus has to be above my vertex because my parabola opens up. So to find my focus, I'm going to add P to my vertex. Well, 4P is equal to 3. So if 4P equals 3, that means P has to equal 3/4. So it means I'm going to add 3/4 to it. Now since I'm going vertical, I'm going up and down, my x isn't going to change, it's the y value that changes. So it's going to be 2 comma 2/3 plus 3/4. And that's going to be 2 comma denominator is going to be 12, so that's going to become 8, I can't draw 8s very well, 12 plus 9/12, and that's 2 comma 17/12. Okay, so my focus is 2 and about 1 and 5/12. So 17/12 is about 1 and 5/12, so about 1 1/2. So that's way up here. So that's where my focus is. Well, my directrix is in the opposite direction. And so instead of adding 3/4 this time, I'm going to subtract. Now, the directrix is a line, so we don't need both x and y. We only need one of them. Because it's going to be a horizontal line, because it never actually touches your parabola. It's below or it's above your parabola. So to the sides. It never intersects it. So in this case, it's going to be a horizontal line that's below. So I only need my y value, and that is -2/3. Oh, geez. I just messed up. And I am sorry about that. I just realized I dropped the negative doing the focus. Okay, let's go back to the focus. I am sorry about that. Notice it's supposed to be a -2/3, so that should be a -2/3. That should be a -8/12. Therefore, this should be a +1/12. I am sorry about that. So that moves my focus from where it was up here down here. Probably much closer than that, but it's close enough. Okay. So now for my directrix, I'm going to subtract the 3/4. Again, same thing, common denominator, so that's -8. Twelves minus 9/12, and that gives me -17/12, or -1 and 5/12. All right. So it's down about 1 1/2, so that's right about here. Okay. All right. Now, the line of symmetry is going to go. It's going to be perpendicular to the directrix, and it's going to go through those two, so it's going to be an x value. So the line of symmetry is going to be x equals 2. And now we just have to do our lattice rectum. Our lattice rectum, again, remember, is our 4p. So LR equals, our 4p is 3. So it's 3 across. So now what I'm going to do is, to graph my parabola, it's got to be 4p across through the focus. You're going to go half that distance on either side, so it's nice and symmetrical. So I'm going to go 1 1/2 across on each side, and then I'm going to sketch it. Okay? And there's my parabola. All right, let's go on to the next example. Okay, this one's not so bad, because what we're going to do is we're going to basically work backwards. We're going to find the equation given the vertex and the focus. So using the information that we know, I'm going to just make a sketch.